Hello, my darlings. We are now moving on to section 1.3, and there's 2 pages, so there's going to be a second little video to watch as well. We are focusing on graphs of functions, and this first thing we're going to talk about is that depending on what part of the graph you look at, the graph could be increasing, decreasing, or constant. So the graph is increasing if from left to right it's going up. It's decreasing if from left to right it's going down, and it's constant if it's just horizontal, so straight across. Okay, so for example 1, we want to determine the open intervals over which the function is increasing, decreasing, or constant. So the intervals, we're talking about the x's. Whether it's going up, down, or constant, we're talking about the y's. So for these x values, the y's are increasing. Or for these x values, the y's are decreasing. Okay, so I for increasing, D for decreasing, C for constant. So increasing right here from left to right, we're going up. And right here from left to right, we're going up. So this would be from negative infinity to negative 2. And then this part would be from 4 to infinity. So decreasing, well, from here to here, the graph is going down. So the x values are from 2 to 4. So it's decreasing on the interval 2, 4. Constant, well, the graph goes straight across right here. So that goes from the x value of negative 2 to positive 2. So that's where the graph is constant. All right, so here you can see we're decreasing, and then we're constant, and then we're increasing, and then we're constant. So increasing went from here to here, and the x values are 0 to 6. Decreasing, well, that was from here all the way down, so arrows go on forever, so that means it starts at negative infinity up to negative 3. And then constant, well, from here to here would be from negative 3 to 0. And then here on forever is from 6 to infinity. All right, another thing we want to look at with functions are called relative minimums and relative maximums. So these are peaks and valleys in the graph. So mainly we've graphed parabolas up until now. And a parabola has either one minimum or one maximum, but we're getting into more advanced graphs now. So if I have a graph that looks like this, it may not just have one maximum value or one peak. Okay, so it's anytime there's a peak in a given interval. So it doesn't have to be the complete top of the graph. So this one, the way I have it drawn, has 2 relative maximums. So this one here, the way it's drawn, has 1, 2, 3 relative minimums. And this one is actually an absolute minimum because that's the lowest the graph ever goes. So it has 3 relative minimums, and this relative minimum is an actual absolute minimum. Okay. So what we're going to do is now approximate the relative minimum and maximum values by point plotting. So we're just going to graph a bunch of points. So looking at this function, I just plugged in a bunch of x's. So plug it in, plug it in, plug it in, plug it in, plug it in. So we plug in these x values and we get out these y values. Please be careful. This is, we cube it and then change the sign. So this is the opposite of x cubed. Here we square the x, then multiply by 3. And some of these went off our graph, and that's fine. I just graphed the ones that I could. And I get the basic shape. So we can see right there is a relative maximum value, and right there is a relative minimum value. So I have a minimum at 0, 0. I have a maximum at 2, 4. And again, I just plugged in a bunch of x values. So remember, this is x squared, then multiply by 3, minus 12 times x. So I plugged in these x values and got out these y values. And I just end up getting this basic parabola shape. So right here is our relative minimum at 2, negative 12, and there is no relative maximum because it's a parabola. Both sides just keep going on up to infinity. And that finishes page 1. I'll see you on page 2.